Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the HCL Link product. Today's topic is generating SSL certificates for Design Server and REST API. Please feel free to reach out to me on LinkedIn at Paul Brett IBM. For today's session, I'm going to be showing how to make a script change so that during an installation of the design server, the REST API will generate custom certificates. We will then execute a selection of keytool and openssl commands to extract those certificates and then reapply them back to design server. In this way, both parts of the product will be using the same secure certificate. So, we're starting our demonstration on a virtual machine, and this machine's host name is VM16xHCL. On this machine you can see that I have HCL Link 110 installed. In the design server directory I only have the two files as delivered. I haven't started this script to unpack the design server yet. I'm going to execute that now and let that run in the background while I show you the REST API directory. In REST API under Tomcat we have no server directory currently, and out of these files that exist here, the one we're really interested in that we're going to edit to create our custom certificates is dtxtomcatservice.bat. However, before I change it, I am going to create a backup folder and copy in all of these files to the backup folder so that I can back out my changes if necessary. So let's edit this dtxtomcatservice file. What we're looking for is a string hcl.com. If we search for that, you'll note that it is part of an argument to a keytool command. Now, instead of hcl.com, we want the certificate to be generated with the host name. So I'm going to pop that in now, VM16xHCL. At the end of this command, I'm going to pop in another argument, -ext, and then in quotes, SAN, which is short for subject alternative name, equals, and then I'm going to put in a couple of entries separated by commas. The first one is DNS:VM16xHCL, then the comma, and then the second entry, DNS:localhost. So if I use either of those names, the certificate will support them. So that's the only changes I need to make to this file. The host name in the CN equals entry and the host name plus localhost as a SAN entry to the EXT argument. I should include this line and the changes I've made to it in the video notes. So let's save the file there. Coming back to the design server directory, we can see that the design server has finished extracting from the zip, and we now can run the install.bat file. So I'm going to drop to a command prompt and do exactly that. Okay, the script has ended and it indicates that the design server application needs to be started by running the start.bat script. So let's do that now. And it now lists everything as running. So let's connect to our REST API first, HTTPS. We will use the host name and the REST API port 8443. As you can see, it's still not connecting without an error, and this is because the certificate authority needs to be set as a trusted certificate authority. So to do this, I'm going to click on the browser not secure button here, click on the certificate, click on the details tab, and then choose copy to file. I'll run through this wizard which will extract the certificate from the web service and put it into a file for us. I'm going to pop it on the desktop and I'm going to get the same name as the host name with a .cer extension. Okay, so that's the certificate extracted from the web server and made into a local file on my desktop. The next step is to import it into the local Windows Certificate Manager store as a trusted root certificate authority. So certmgr.msc to run the certificate manager. Go onto the trusted root certificate authorities and expand and click on certificates. You will note that there is currently no certificate that begins with VM. So we right click on certificates and from all tasks choose import, and we're going to grab the file that we put on the desktop just now. Next, we're going to place it in the trusted root certification authorities store. Next, finish, and once that's done it appears in this list here. Let's close that. If we now fire up our REST API link, you will note that it goes straight in. You will note that the padlock is there. If we try to click the Manage App button, this will not work because there is another change that we need to make that work. Access denied. This is what I was expecting. So let's make that quick change now. We're going to go to the REST API directory. We're going to go into Tomcat, into Server, into Web Apps, then Manager, and finally meta-inf. We're going to edit the context.xml file, and we're looking for this line that starts with valve class name, and we're going to make it into a comment by adding less than, exclamation, dash dash, and at the end of the second line here, dash dash greater than. Let's save the changes and close. The next time we access the REST API using the host name on port 8443, we go straight in, we've still got the padlock, and then we click the Manage App button and we get the prompt to log in with username and password. By default these are both set to admin, and there we go, we get into the manager of the applications, one of which is hiprest, and if we click on that, hiprest tells us that it's up and running. I've got a couple of shortcuts on my desktop, one that goes to the hiprest swagger page. We'll click on that and you'll note that we're straight in. All of the API is available there, and you'll note that we've got the padlock in the address bar. Let's close and we go into the REST API endpoints page, and you'll note that I've got no maps deployed currently, but we're in the page and the padlock is there. So that's fantastic. The change we made to the dtxtomcatservice.bat file has successfully done what it was supposed to and created us a custom certificate instead of the one that is delivered with the product. And the REST API is using it. Let's see what happens when we try to connect to the design server. We're going in on the standard port for HTTPS, which is 443, because it's the standard one, we don't need to actually specify it. And you'll note this says not secure. If we click on the not secure and look at the certificate that's being provided, you will note that it still says just localhost. This is because Design Server uses a different mechanism of reading certificates, and now we need to change Design Server to use the same certificates as the REST API. How do we do that? Okay, back in the Design Server directory, we have a directory client. Within there we have SSL certificates, and then within that we have a private certificates folder. These are the two certificates that are used by default. The service will expect to find these two exact named files in this location. So what we need to do is back up these two files and then use a couple of keytool and openssl commands to generate replacement files from the keystore that we've created in the REST API. Now to do that I've got a batch script that I've created earlier. I'm going to show you the content of that script and then I'm going to execute it. So the first thing that the script does is change to the drive and path where the script was called from. Then it's going to add an entry to the path variable so that it can find the keytool library that we use later. These two lines do my backup for me, so I keep a copy of the existing certificates in case things go wrong. And the next 4 lines in 2 pairs of 2, the first one, the keytool and the openssl commands to extract the server certificate and create a PEM file. and the second pair of lines, the keytool and the openssl command to extract the private key from the keystore. I'll go through the individual items in this keytool. So first of all, we're saying we want to export. We want to export an alias that is listed as dtxtomcat. Now it's worth bearing in mind at this point that we can set the REST API to use an alternative keystore than the one that is delivered if, for example, you have a private certificate already that's been issued by one of the known certificate authorities. You can change the REST API to use your file, be it a JKS or PKCS12. And if you do that, you can carry on using these commands to extract the two certificates we need. But the only difference would be that where we have a file here that's pointing to, a keystore here that's pointing to a specific keystore, which is in the REST API directory, you would place in your own keystore there instead. Now the file we're going to be writing out in this particular line is server-crt.der. This is going to be a binary representation of the server certificate. And finally, we need to tell it that the keystore that we're reading from, dtxtomcat.keystore, is the store type PKCS12. Okay, so that's the keytool command. It creates a binary certificate. The next command, the openssl, basically reads in the incoming DER file, server-crt.der, and writes it out as server-crt.pem, an ASCII representation of the same. And you will note that this is the final file name that we need. The next two lines do exactly the same thing as the previous two lines, but instead of extracting a certificate, they extract the private key. So let's run this batch file now. Whilst running it, I will be prompted several times for a store password. For the store that exists currently with the product, the certificate store password is defined as change it. Occasionally it will also ask me for a password for the new key store that I'm creating. I'm also going to use change it just to keep things nice and simple. So we have to put this in several times. Okay, so the script has finished, and you will note that I've got two .backup files. They're the original PEM certificates that have been backed up, and I also have two new PEM files. Now to get the design server to use these, all we have to do is stop and restart the design server. So back at the design server script window, I'm going to issue the stop command. And now that it is stopped, I'm now going to issue the start command. Okay, it now reports that the application has started again. Just to show that the REST API has not been broken by the commands that we've just done, I'm going to bring up the REST API first. And as you can see that we've gone straight into the Apache Tomcat screen, and we have the padlock. So the REST API is still behaving exactly as we would expect. Let's bring up the endpoints page. And there we go, straight into the HCL link endpoints, padlock in place. Okay, so let's try and fire up the design server. I'm going to take the 8443 off the end and let it connect to the standard 443 port. And as you can see, it goes straight into the design server login page, and we have the padlock in the address bar as expected. So why would you want to do this? Well, if, for example, you're embedding HCL link in HCL Unica campaign or HCL Unica journey, if one of those two products uses a certificate already and you're connecting via HTTPS, you will not be able to connect to the embedded HCL link design server if it is not already also communicating in HTTPS. So it is essential that your design server connects HTTPS before you even attempt to integrate it with HCL Unica campaign or journey. And that's the end of the demonstration. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. feel free to reach out to me on LinkedIn at Paul Brett IBM. Thank you.